Hi guys, welcome back to my channel. Thanks for such good response on my previous videos. Keep supporting my channel, like, share and subscribe to my channel. So without any further delay, let's get started with today's video. So today's topic is on mathematics. So my name is Rudana Srinivas from third semester CSC CY. Today's topic is standard error. Introduction to standard error. Standard error is a measure of variability or dispersion of sample statistics. It provides an estimate of uncertainty in the sample statistics. It is calculated as the standard deviation of sample statistics. It is used to refer an estimate of the standard deviation derived from particular sample to compute a estimate. So let us see the importance of the standard error. Standard error helps to determine the precision of the sample statistics. It allows us to make inferences about the population parameter based on sample statistics. It is crucial for hypothesis testing and constructing confidence intervals. So here is the graph of percent versus difference in proportion. So the graph of standard error is about 3.3%. This measures the variability of the sample statistics. This graph is tells about the difference in proportion of cases and controls who took antidepressants. This studies is done on about 263 crores and 1241 control, that is 1241 controls. This slide is about calculation of standard error. So, for sample mean, the standard error is calculated as the standard deviation divided by the square root of sample size. So, let us see the formula. Here SE stands for standard error, N stands for sample size, sigma stands for standard deviation. Here, the formula says that the SE is equal to sigma by root N. That tells the standard error is equal to standard deviation divided by square root of sample size. So for the better understanding, let us go through the example given here. Example says that n equal to 5, given that n equal to 5, sigma equal to 17, we get the standard error is equal to 17 by square root of 5. The standard error is equal to 7.6. For the sample proportions, the standard error is calculated as the square root of p into 1 minus p divided by n, where p is the sample proportion and n is the sample size. So go through this formula and remember it. Important formula. So let us go back to the next slide. Relation between standard error and sample size. So as sample size increases, the standard error decreases. It's evidently shown in the graph that as the standard error increases, the standard error increases, the sample size decreases. So this is a graph of standard error with sample size. Here, as the standard error increases, the standard sample size decreases. So the larger the sample size provides more precise estimate and reduces the uncertainty in the sample statistics. The standard error is inversely proportional to the square root of the sample size. We have already gone through this formula while calculating the standard error. The standard error says that it is inversely proportional to the square root of sample size. When we went to the formula, we get it that the standard error is equal to standard deviation divided by square root of sample size. So it can also be prosecuted as the standard error is inversely proportional to standard square root of sample size. Standard error versus standard deviation. Let us go through the differences between the standard error and the standard deviation. Standard error means the measure of variability of the standard statistics, while the standard deviation measures the variability of the individual data points. So here is the clear difference. The standard deviation describes the spread of data within a sample, whereas the standard error quantifies the uncertainty in estimating a population parameter. Standard error is used to describe the data itself, while standard error is used to describe the precision of the sample statistics. So here are the three differences between the standard error and standard deviation, which is evidently saying that standard error is different from standard deviation. Let us now go through the calculating the standard deviation. So we already know how to calculate the standard error. So let us now learn how to calculate the standard deviation. So standard deviation, the formula is standard deviation, that's S x equal to square root of summation of I equal to 1 x I minus x bar the whole square divided by n minus 1, where n stands for number of data points, xi stands for each of the values of the data, whereas x bar stands for the mean value of the xi. So here we can calculate the standard deviation using this formula. This formula you can use to calculate your standard deviation. So there's also the normal curve given here, normal distribution curve. Go through this. Let us go to the next slide. Okay, the next slide is on confidence intervals and standard error. Confidence intervals are constructed using a standard error. So the confidence interval provides a range of values within which the true population parameter is likely to lie. So the confidence intervals have a range of values. The margin of the error in the confidence interval is determined by the standard error. The margin of the error in the confidence interval is measured by this standard error. So we can express the confidence interval as x bar power plus or minus m, where m stands for margin error. The confidence level C indicates the success rate of the method that produces the interval. It represents the area under the curve within plus or minus m of the center of the curve. Two endpoints of an interval mu possibly within x bar power minus plus x bar plus m. Here is an example given where the example is 114 to 126. Mu is the area under the curve. Probability between these 2 points area is 1 minus c 2. This curve is known as the standard normal curve. The distance between these 2 points is x bar, that is x bar minus power minus m, x bar power plus m. So standard error in regression analysis. In regression analysis, standard error is used to measure the accuracy of estimated regression coefficients. It allows us to determine if the estimated coefficients are statistically significant. Smaller standard errors indicates more precise estimates and stronger evidence for the relationship between variables. So calculation of standard error of regression is given here with few examples, where this row stands for independent variable, this column stands for dependent variable, and this is the predicted value using y is equal to 1.0884 x plus 107.21. The error is given here using the formula C5 minus D5. That is the column phi minus deviation. So let us go through this table. Standard error in hypothesis testing. Standard error is essential in hypothesis testing. So This is also one of the main important application of standard error. So hypothesis testing is an application of standard error. It helps to calculate the test statistics and determine the probability of observing the sample statistics under the null hypothesis. If the test statistics unlikely to occur by the chance, we reject the null hypothesis. Here is the curve. In the test statistics is the rejection region. So reject H0 if Z is less than minus 1.96 or greater than 1.96. Otherwise, do not reject H0. Common misinterpretation of standard error. So let us go through the interpretations of standard error. Standard error should not be confused with standard deviation or range of data points. It's very normal that we get confused between the standard deviation and the standard error even while spelling it. So the standard error is very evidently different from the standard deviation. In the previous slide, we went through the differences between. It is not to measure the spread of individual data points. So the standard deviation is to measure the spread of individual data points, but standard error is not to measure the spread of individual data points. Standard error does not provide information about the distribution, shape, or skewness. Research and statistics standard error of mean. So the common misinterpretation of standard error is that it should never be confused. It has standard deviation. So it's clearly shown here. The research and statistics, the standard error formula is sigma by root n, square root of n. Conclusion. So let us come to a conclusion that what standard error is. Standard error is a crucial concept in statistics that quantifies the uncertainty in estimating the population parameters. It is used to measure the precision of sample statistics and is essential for making inferences and constructing confidence intervals. These are the useful points of standard error and its applications. Understanding of standard error is a fundamental for interpreting the research findings and drawing meaningful conclusions. Thank you for watching this video. Please do like this video, share and subscribe to my channel for more such videos.